questions 8 to 10 of the 2001 grade 12 Euclid math contest. On the grid provided in the answer booklet, sketch x squared minus 4 is equal to y, and y is equal to 2 times the absolute value of x. All right, so let's draw a little graph here. We've got x-axis, y-axis like that. Let's label this. We got x and y. And then the first one, y is equal to x squared minus 4. When x is 0, y is negative 4. So it'll be right there. That's most likely the vertex of that parabola. And then to get the x coordinates, set y equal to 0. So you'll have x squared minus 4. And that means x squared is equal to 4. And then x is equal to plus or minus 2. So approximately here and here, 2 and minus 2. So it's a parabola, so it's going to be basically something like this. And then the next one is y is equal to 2 times the absolute value of x. So this has two scenarios, right? When x is greater than 0, this just becomes y is equal to 2x. And when x is greater than or equal to 0. And when x is less than 0, this becomes y is equal to negative 2x. Like that. So let's start plotting here. Obviously 0, 0 is part of the graph. So when x is 0, y is 0. And then when you keep putting in numbers for x and y, they will be the same, except you'll have to multiply by 2. So when x is 1, it'll be 2 for y. When you have x is 2, it'll be 4 for y. So it'll basically be a line kind of like that. And then it keeps on going. In the other quadrant, x is less than 0, you'll have a very similar scenario, but you are going to use this equation. When x is negative 1, for example, it will be negative 2 times negative 1, which is y is equal to 2. So it'll be like negative 1 is here, so this is 2 approximately. And then when x is negative 2, it'll be negative 2 times negative 2, which is positive 4. So it'll be approximately here. So this part will be like that. So that is the graph of y is equal to 2 times the absolute value of x. And this parabola is the graph of y equals x squared minus 4. Determine with justification all values of k for which y is equal to x squared minus 4 and y is equal to 2 times the absolute value of x plus k do not intersect. Okay, so we do not want these two to intersect. These are the two equations. Remember, if they intersect and you set them equal to each other, you would be able to find a common solution, but we don't want them to intersect, so somehow we have to make this not work. All right, so we have two scenarios. Basically, we have one where x is greater than or equal to 0. In that case, it becomes x squared minus 4 is 2x plus k. And the other scenario is when x is less than 0. That would basically become x squared minus 4 is equal to minus 2x plus k. These are our two formulas. So let's start with the first one, and then we'll go to the second one. The first one would give us x squared minus 4 is equal to 2x plus k. And therefore we have x squared minus 2x minus 4 minus k is equal to 0, like that. And this is probably going to be a quadratic. So just write it out in the standard form. Minus 4 minus k, like that. And therefore x is equal to minus b, right? Our standard quadratic equation, plus or minus the square root of b squared minus 4ac all over 2a, like that. And we don't want this to work. So if we don't want this to work, one way is to make sure that this gives us imaginary solutions, and that will happen if this discriminant, this part in there, is less than 0. So I'll write that in a sentence form. If the discriminant b squared minus 4ac is negative, this will give no real solutions. So set this equal to less than 0. So what we have here, we have 4 minus 4 times minus 4 is plus 16, and minus 4 times minus k is plus 4k. And we want to set that equal to less than 0. So this becomes 20 plus 4k less than 0, and therefore 4k is less than minus 20, and k is less than minus 5, like that. So if k is less than minus 5, these two will not intersect. But we have one more scenario, and that is this one right here, number 2, if x is less than 0. So let's do that one. X squared minus 4 is equal to minus 2x plus k, and therefore x squared minus 2x plus minus 4 minus k is equal to 0. Sorry, this was a minus and that's a plus. All right, so similar to the other one. All right, so now same story, right? We will have to get the discriminant less than 0. So what is the discriminant? It's b squared minus 4ac. So in this case, it would be 2 squared minus 4 times 1 times minus 4 minus k is less than 0. And therefore, this is 4 plus 16 plus 4k. And it looks very familiar. I think it's the exact same, actually. And therefore, 4k is less than minus 20, and therefore k is less than minus 5. All right, for both scenarios, if k is less than minus 5, these two will not intersect because the discriminant will be less than 0, and that will not give real solutions. All right, now we have part C. State the values of k for which y equals x squared minus 4 and y is equal to 2 times the absolute value of x plus k intersect in exactly 2 points. Okay, justification not required. All right, so we have a few scenarios, right? So for the first graph, or first equation I should say, right here, y is equal to x squared minus 4, it's going to be a parabola with fixed points. So something like this, right? And similarly, all of those are going to be the same for that one, because that one is fixed. So I'll just draw that for all of them. Now what changes, of course, is this guy right here. That's going to be several scenarios, so we'll go through each scenario. The first one is when it's all the way down here. If that's the case, these two are never going to intersect, because this is going to go all the way up, and the orange one, which is this graph right here, it's not going to ever intersect. So that one will give you 0 points of intersection. The next scenario is if it comes up and it just touches like that. You see how it just touched it? like that. So you got one intersection point and two intersection point. 2, that's the one we're interested in. We'll find a few more. The next one is a scenario that's like this. I apologize for the bad artistry. But if you notice, this one has 1, 2, 3, 4 intersection points. But we don't need to worry about that. But it's important to understand that can happen. And then another scenario is right here. Like that. Where you have 1, 2, and exactly 3. The vertex of the parabola and I guess the vertex of that V-shaped orange graph intersect. So this is 3. And then finally, we have this kind of scenario like that, where it intersects at 2 points. So that's 2. So we are interested in this one and this one, because that's what the question asks. What are the values of k? All right. Well, if you remember, this point right here was, what was it for the y-axis? X was 0, so this was -4. Okay? So if k is moving this graph up and down, it originated, if you remember, without the k, y is equal to 2 absolute value of x, was right here, right? You remember we drew that actually. We drew it, well, it's gone now, but we had drawn it. If you remember, well, it was just a few minutes ago. Now, the k, what it does is it moves it up and down, all right? So if k is, say, -5, it would bring the graph down to -5. Okay? So this scenario, the first one, happens when k is less than -5. And we also figured that out in the previous question, that we had to figure out a scenario where when do they never intersect? When they never intersect, there. We didn't draw the graph in the previous one, but that's exactly what the graph will look like. So the first two questions help us with the part C. Now we get to this next scenario, 2 intersection points. Well, this happens when k is exactly equal to -5. Okay? And then that's what this point is, -5. So this actually would probably be a little bit lower. The -5 would not be there. So it's probably better to label it like that. How about 4? Well, 4 happens when k is between -5 and -4. How do we know that? Well, we know that probably because it's easier to figure it out for 3. This happens when k is exactly -4, right? Look how they join the vertex of the parabola and the absolute minimum of the orange graph. And finally, when k is greater than -4, we get into this scenario. So with a little bit of kind of, graph drawing and comparisons, you can get these scenarios, and part A and part B definitely helped us with this also. So we are interested in exactly 2 intersection points, which is this scenario and that scenario, and they happen when either when k is equal to -5 exactly, or when k is greater than -4. Triangle ABC is a right-angled at B and has side lengths which are integers. A second triangle, PQR, is located inside ABC as shown, such that its sides are parallel to the sides of ABC, and the distance between parallel lines is 2. Determine the side lengths of all possible triangles ABC, such that the area of ABC is 9 times the area of PQR. So I've got some labeling to do here. This part here and that part there, those are all 2. They even label that in the diagram. This part here is 2, and so is this part here. And then I'm going to draw lines to that side because that's also 2. And that's also 2 because they tell you that. And then we will draw lines from A to P and then R to C like that. And I think that should be it for lines. Now let's start labeling. This whole side BC I will call A, like that. Let's move this up a bit. This whole side AB I will call C, since it's opposite that C. And this whole side over here I'll call B. And I think so far that's all I know. I'll just label this 2, 2, like that. And similarly for the small triangle inside, this side I will call R, that distance there. This distance here I will label as P, and that hypotenuse I will label as Q. All right? And therefore this distance from there to there is Q, and that distance from there to there is R, and this distance from here to here is P. Okay? Now we have some similar triangles. We have this triangle PQR is similar to ABC, and I hope you can see that because they're all parallel. The sides are all parallel. They tell you that in the question. So that means that if you look at the way I labeled it, if you have R, write it over here, R over P, so this R over P is the same as, if you look at the big triangle, C over A. So this C over this A. And this will give you several relationships. For example, it will give you that PC is equal to R times A. And from that you'll get that P is equal to RA over C. And you'll get that R is equal to PC over A, and so on. There'll be a lot of relationships there, and we'll use those hopefully later on. But that's important to create. Now let's look at what they give us in the heart of the question, that the area of ABC is 9 times PQR. So area of ABC would be 1/2 base times height, which is base is A, and the height is C. So 1/2 A times C. And that is equal to 9 times the area of PQR, which is 1/2 base times height. The base is P, and the height is R. So P, R, like this. The halves cancel, so all you're left with is AC is equal to 9PR, like that. So this is AC, 9P, but R, we can substitute this right there, and that would become PC over A, like that. And if you cross multiply, you'll get A squared C is equal to 9P squared C. The C's cancel from both sides, and you get A squared is equal to 9P squared. And if you take the square root of both sides, you'll get A is equal to 3P. So that is our first relationship. A is equal to 3P, like that. All right? And in a very similar way, let's see if I can stay on this page. We can figure out a relationship between C and R. This C right here and this R right there. So again, using this formula right here, AC is equal to 9PR, right? Because the halves cancel. AC, this time For P, I will enter this one right here, RA over C. So I've got 9RA over C. Cross multiply the C and you get AC squared is equal to 9R squared A, like that. The A's cancel and you're just left with 9R squared is equal to C squared. Take the square root of both sides and you get C is equal to 3R. So there's another relationship what we have. C is equal to 3 times R. Okay, and then finally, running out of space, but I'll squeeze it in there. We want to figure out a relationship between Q and B. Well, no problem. C here over B, which is the hypotenuse, is the same as R over that hypotenuse, Q. So R over Q. And therefore, because C is equal to 3R, we can substitute that in. And we get 3R over B is equal to R over Q. The R's cancel and you're just left with 3Q, if you cross multiply, is equal to B. So there you go. B is equal to 3Q. And that is going to help us move forward. So now let's move this up a bit. Here we go. We need a little bit more space. And let's clean all this up a bit, but let's keep the diagram. So now I'm going to label P and R and Q in terms of A, C, and B. So we have a relationship that A is equal to 3P, right? So that means that P is equal to A over 3, like that. And similarly, R is equal to C over 3. C over 3, like that. And Q is equal to B over 3. All right? Now, look at BC. So, look at this line down there, BC. We have this whole line is equal to A. That's what I had labeled it. And therefore, this part here is going to be A minus 2 minus A over 3. Correct? And if you do the math there, you'll get 3A over 3 minus A, so 2A over 3 minus 2. Okay? That part that I highlighted in red is 2A over 3 minus 2. And in a very similar way, we want to get this height right here. That is going to be C. Need a little bit more space. That is going to be C minus 2 minus C over 3. And if you do the math there, you will get 2C over 3 minus 2. And by symmetry, this is the same. It's 2A over 3 minus 2. And similarly, that is the same. It's 2C over 3 minus 2. And this part here, Q, is B over 3. All right? So now I want you to look at AC. From A to C, that big long hypotenuse. Like that. AC is equal to this guy, 2C over 3 minus 2, plus that one, plus B over 3, plus this one right here, 2A over 3 minus 2, like that. And that is equal to AC, but AC we had labeled originally as B. So there you go. That's our equation. So multiply through it all by 3. We get rid of the fraction. So we got 3b equals 2c minus 6 plus b plus 2a minus 6, like that. And that would, let's see, the b's, that would become 2b. and then 2c plus 2a minus 12. Divide through by 2, and you get b is equal to c plus a minus 6. Okay? And that is a good relationship to have. Now we will use the Pythagorean theorem on the entire triangle for a, b, and c. This side, of course, is c. This side is b. And this side is a. All right? So we have a squared plus c squared is equal to b squared, like that. A squared plus c squared. And then b squared, we can use that to substitute. So c plus a minus 6 all squared. Okay? And now we can move forward and do the algebra here. So I'll bring it over here. We have a lot more space there. So we got a squared plus c squared is equal to c plus a minus 6 all squared. So that would be c squared plus 2c a minus 6 plus a minus 6 squared, like that. C squareds cancel, so we're just left with a squared is equal to 2ac minus 12c. And then this is a squared minus 12a plus 36. All right? A squareds cancel again. Great. So now we're left with 0 is equal to 2ac minus 12c minus 12a plus 36. And at this point, let's see, anything, we can divide through by 2. AC minus 6c minus 6a plus 18. And I think we can get everything in terms of c. So let's put everything without the c on one side. So that would be 6a minus 18. And that would leave ac minus 6c. And then we can factor the c. A minus 6 like that. 6a minus 18. All right, things are looking like it's going to work out here. So now we can put all of this over here and divide by a minus 6. Okay, so we have finally a relationship. C is equal to 6a minus 18 all over a minus 6. And remember, our goal is to find a, b, and c. Well, unfortunately, this is all we have in terms of an equation. So we're going to have to use inspection because there's no second equation. So I'll break it up like that, and that will make our inspection a little bit easier. When you break it up like this, I want you to concentrate on this term right here. Remember, these are all integer values, so c is an integer. The only way you're going to get an integer is if this is an integer, the one I circled in red. So therefore, that means that a minus 6 is the denominator and 18 is the numerator. So 18 divided by a minus 6 has to be an integer. How do you do that? Well, a minus 6 must be a divisor of 18. So on the side there, a minus 6 has got to be a divisor of 18. So what are the divisors? We have, let's see, 18, 9, 6, 3, 2, and 1. If a minus 6 is equal to any of these, this would give an integer, and most likely c would become an integer also. So let's go through this. If a minus 6 is equal to 18, a would be 24. If it's 9, if a minus 6 is 9, a would become 15. And going through this, you'll get 12, 9, 8, and 7. Okay? Now, if you take these values for a and you plug them back into our formula right here, this one, you'll get values for c. And the values are 7, 8, 9, 12, 15, and 24. Okay? And if you then take these values and plug them back into right here, this one right here, b is equal to c plus a minus 6. b is equal to c plus a minus 6. I'll just do the first one. b is equal to 7 and 24. 7 plus 24 minus 6. That's 31 minus 6, 25. So you get b is equal to 25. And similarly, the other values are going to be 17, 15, 15, 17, and 25. All right? Now, one final step is that a lot of these are similar, right? You got 24, this one here, ABC, is 24, 7, 25. But this is also the same. It's just, different reversal. So the only distinct triangles are 7, 24, 25. That's one distinct one. The other ones are similar or the same. There's another distinct one that's 8, 15, and 17. And the final distinct one is 9, 12, and 15. So there you have it. Those are the values for A, B, and C that you get that will make this whole thing work. And what we really were trying to prove is that this right here, ABC, such that the area is 9 times the area of PQR. Points P and Q are located inside the square ABCD, such that DP is parallel to QB and DP is equal to QB is equal to PQ. Determine the minimum possible value of ADP. So I'll draw this a little bit bigger here. Now let's start labeling things. First thing I'm going to do is draw a diagonal from D all the way to B like that. Okay? And next I'm going to label some angles here. We are interested in angle ADP. ADP, this one right here. So I will call that theta. All right? And then this angle here, because it's a square, is a right triangle. And then if I drew that green diagonal, that means that this is 45 degrees. Right? And this is a right triangle also. And therefore this guy in there, since this is also 45, that is going to be 45 minus theta. Minus theta. Okay? So I hope that makes sense. And then DB, we can easily figure out quickly through Pythagoras. Did they give us any? No, they didn't give us any side length. So we'll just call it something. We'll just call it 1, make it easy. So DB would therefore be, DB squared is 1 squared plus 1 squared. So DB is equal to root 2. All right? And any other, they don't give us much information here at all. So we're going to have to label something. PD, this length right here, I'm going to have to label it something. So I'll call it X, PD. And PR, R being the midpoint right here. You see I wrote this diagonal. I drew that diagonal from D to B. It's going to cut PQ in half. And that point that it cuts it, I'm going to call that R, the point right there. And therefore PR is X over 2 because R will cut PQ in half. And PQ is the same as PD. PQ is the same as PD or DP, same thing. So if R cuts PQ in half and PQ is equal to X, PR will be X over 2. All right? And I think that's it. That's all we get. So somehow, by some miracle, we have to figure this out with such limited information. All right. So one thing that we are always going to have to use, and they're very popular on the Euclid exam, especially in the latter questions, number 10, number 9, is something called the law of cosines. And if you're not familiar with it, please review it. I think there was a law of cosines earlier in this contest. I can't remember which number it was, but I did it just a few minutes ago. So the first law of cosines I'm going to do on is PDB, triangle PDB. PDB. So where's PDB? It's right here. PDB. So I guess I have to draw in a connection from P to B to make that a triangle. And there you go. All right, so let's go with this now. PB squared is equal to PD squared plus DB squared minus 2 times PD DB and cos of which angle? The one opposite PB, which is 45 minus theta. All right, barely squeeze it in there. All right, anything that we can plug in, PB squared, PD is x, so we put that in there. DB is root 2, so root 2 squared would be just 2. And then, yeah, we can put in x's and things like that. So we got x and root 2 cos 45 minus theta. Okay? And instead of keep writing PBs, I'm just going to label it y. It just makes it so much easier. All right. So y squared is equal to x squared plus 2 minus 2 root 2x cos 45 minus theta, like that. And I'm trying to isolate for 45 minus theta because I'm going to get the same relationship with another triangle. So I can do that by putting it all over on one side. 2 root 2x cos 45 minus theta, like that, is equal to x squared plus 2 minus y squared. And therefore cos of 45 minus theta, like that, is equal to x squared plus 2 minus y squared all over 2 root 2x. Okay? So that is the first of two relationships for cos of 45 minus theta. To get the next relationship, I'm going to use triangle PDR. So where's PDR? P is there, D is there, R is there. So that guy right in there. Okay, that triangle. So here we go. Let me just get in the relationship and then I'll move it all the way up. So PR squared, I can't even see P. There's P. PR squared is equal to PD squared plus DR squared minus 2 PD times DR times the cos of 45 minus theta. All right? Okay, now I can move it up. All right. So PR, if you don't remember, PR was x over 2. Okay? So PR is x over 2, all squared. Is PD was x, right? There's PD right there. We had called it x right here. And that squared dr is, oh, I hate to keep going back and forth, but dr is basically from here to here, right? And db was the whole diagonal from there to there. So dr is obviously half of that. So it's root 2 over 2. All right. Hopefully that's the last time I have to keep going back. So we got root 2 over 2 all squared. And 2 minus p dx, and dr was root 2 over 2. Okay? Cos 45 minus theta. All right. Okay, no algebraic mistakes, please. X squared over 4 is x squared. And this looks like 2 over 4, which is a half. Minus, those 2's cancel, so you get root 2x cos 45 minus theta. Okay, getting somewhere. Remember, we have to isolate for that. So bring that over to the other side, root 2x cos 45 minus theta is equal to x squared minus x squared over 4 plus a half. And this looks like common denominator 4 and 4. So 3x squared over 4 plus a half. And that looks like 3x squared plus 2 over 4 is root 2x cos 45 minus theta. And then finally, we can isolate 45 minus theta is 3x squared plus 2 over 4 root 2x. All right, so we got another one. So we had this one and this one. So since we have two relationships, we can set them equal to each other. So the first one was x squared plus 2 minus y squared over 2 root 2x. So x squared plus 2 minus y squared over 2 root 2x. And that is the same as this guy, because that's also equal to cos 45 minus theta. So 3x squared plus 2 over 4 root 2x. All right, move it all the way to the top. Finally, we get a full screen. Okay, now we got to work with this one here. So let's see, the root 2x's in the denominators go. And therefore, if I cross, actually, yeah, those go, and then this goes, and that just becomes a 2. All right, so I hope you understood what I did there. Cross multiply the 2, and you get 2x squared plus 4 minus 2y squared is equal to 3x squared plus 2. And let's see here, the x's can be combined to just give x squared, and the 2 can be brought over to give just 2 minus 2y squared, like that. And I'll isolate for x or y, it doesn't really matter, but I think y is better because we only have one y in our formulas, so just isolate for that. 2 minus x squared is equal to 2y squared, and therefore y squared will be equal to 1 minus x squared over 2. Okay? So now we can finally get everything in terms of one variable. Right here, we can put y squared into there, and that will help us figure out a relationship for this angle. Because this one here, I think, is a dud. It doesn't really give me anything. So let's see if this one does. So I'm going to take this equation, and I'm going to substitute into it what we just found for y. So that equation was cos 45 minus theta is equal to x squared minus y squared plus 2 all over 2 root 2x, right? X squared minus y squared plus 2 all over 2 root 2x. X squared minus y squared plus 2 all over 2 root 2x. Okay, good. I didn't miscopy it. That'd be the ultimate nightmare. All right, so now let's plug in this value of y squared. So we got x squared minus 1 minus x squared over 2 plus 2 all over 2 root 2x. All right? Simplify this in any way you feel you want to. Let's see here. X minus squared minus 1 plus x squared over 2 plus 2 all over 2 root 2x. And this looks like x squared over 1 plus x squared over 2 is 3x squared over 2. And then 2 minus 1 is, of course, just 1 all over 2 root 2x. And this looks like if you put it individually, it'll be 3x squared over 2 times 2 root 2x plus 1 over 2 root 2x, like that. And then a lot will cancel here. The x's will at least, well, maybe not a lot, but that will at least help us a little bit. And the bottom just becomes 4 root 2. Yeah. And this is just 1 over 2 root 2 x. And anything we can factor out from the denominator, I think we can factor out a 4 root 2, and that would give us 3x plus 1 over x, actually 2 over x. Yeah. And that's it. That's about as far as we can go. And let's not forget what it was, cos 45 minus theta. Okay? Now at this point, there's a little bit of trickery that we need to do. And before I continue, I have to sort of explain it. Otherwise, it'll be very difficult to understand. So note something as an aside, that if you have a minus b, right, and you square it, it becomes a squared minus 2ab plus b squared. You all know that. And regroup this, a squared plus b squared minus 2ab. Okay? Now, a minus b all squared is always going to be a positive, right? Because you've squared something. So this is always greater than or equal to 0. And therefore, this is always greater than or equal to 0. And therefore, if you bring the 2ab over to the other side, a squared plus b squared is greater than or equal to 2ab. Okay? So this is a relationship that we will employ up here. How? Well, by letting 3x equal to a squared, okay, this guy, and letting 2 over x equal to b squared, this guy. And if you do that, a little bit of magic happens. We basically get the following, that this 3x plus 2x, or 2 over x, I should say, which we set as a squared and b squared, is greater than or equal to 2ab, just like how we have up there. Now, what is our a and b? Well, a would be root 3x, so put that in there, and b would be the square root of 2 over x, so the square root of 2 over x, like that. So the square root of 2 over x. Okay? And then if you keep simplifying this, you get 2. Everything under the square root will become 2 times 3, which is 6, x over x, like that. And the x's cancel, so you get 2 root 6. Okay? So I hope you followed what I did there. I know it's very, very tricky, but that's how you do it. So now we proceed with this guy. cos of 45 minus theta is equal to 1 over 4 root 2 times 3x plus 2 over x. And this is, based on what we did here, greater than or equal to 1 over 4 root 2, and this part is greater than or equal to 2 root 6. Okay? So I hope you see how that happened there. Pause it, rewind it if you don't understand it, and watch it again. And then therefore this simplifies to, we get 2 over 4, and under the root sign we get 6 over 2, like that. And then therefore this is 1/2 times 6 over 2 is 3, so root 3. Also written as root 3 over 2. Okay? So that we have come all the way to this point, that cos of 45 minus theta is greater than or equal to root 3 over 2. And if 45 minus theta, or the cos of it rather, is equal to root 3 over 2, then 45 minus theta would be equal to 30 degrees. And therefore theta would be equal to 15. And that is our answer. That is our minimum value. Now, if you're not convinced, you say, well, what about if cos 45 minus theta is greater than root 3 over 2? Right? You set it equal to the root 3 over 2, but what if it's greater? Well, if it's greater, let's choose a value. So let's say root 3 over 2 is what? Approximately 0.8 or something. So let's say we set it equal to, say, 0.9. Right? We want it greater than that. We'll take out your calculator and figure out what's 45 minus theta. It'll be about 25.8 degrees, and therefore theta will be 45 minus that, which is about 19.1 degrees. Right? So this angle is greater than 15. They wanted the minimum. I'll go all the way back to the beginning. So they wanted the minimum, right? Determine the minimum possible value of ADP. ADP was that angle in there, which is theta. So based on our calculations, our relationships, the minimum we can get for theta is 15. And that happens when the cos of 45 minus theta is set equal to root 3 over 2. If you use our relationship and set cos 45 minus theta greater than root 3 over 2 like I did here, our values for theta will always be greater than 15. So number 10, the minimum value for theta is 15.